In this MCQ from NCERT example, it said the adjusted frequency of the class 25 to 45. So I can see this is the class and its frequency is given as 8. We have to find its adjusted frequency. So for that, you have to remember the formula of the adjusted frequency. Let's say if I write down the formula of adjusted frequency, this is what we use for calculating this. So adjusted frequency is what? That is the minimum class size. When you look into the class size, here the class size is 5, 5, then 10, and then this is 30. So the minimum is what? 5. So the minimum class size is 5 divided by the class size of this, which is how much? Class size is what? Upper limit minus lower limit, right? That is 45 minus 25. So it give you how much? 20. So this is 20. That multiplied by the frequency of this class, so which is 8 in this case. I can see that we can reduce it by 4 times and 4 2 times. So we'll say that 2 is the adjusted frequency of this. So we have an option. Yes, it is. Option D is the correct option in this case. In this question, it says for a frequency polygon of a continuous frequency distribution, we plot the points whose ordinates are what? The frequency, right? Frequency of the respective class and abscissa are. So more clarity will come if I show you a frequency polygon. So you can see this is a frequency polygon drawn over here. Now check here, if I ask you, how did I take this point A as? So you will say that A, the x coordinate of A is this, and the y coordinate as say this, right? Where x coordinate is also called abscissa and the y coordinate is called ordinate. So they are saying that ordinates are what? The frequency. So that's what they have already given, that ordinates, that is y coordinate, right? Ordinate is frequency, which is correct. As you can see, the frequency is on the y-axis. And what is on the x-axis? The on the x-axis, that is the x coordinate is what? The class mark, which is also called the midpoint. So if I look into this, yeah, this says yes. C is the correct answer. That is class mark. So remember one more time, whenever we plot a frequency polygon, its x coordinate, any point whose x coordinate is the class mark and the y coordinate is the frequency. So x coordinate is also called abscissa, right? And the y coordinate is also known as ordinate. To understand this, I have taken one more question. It says to draw frequency polygon. You can see this is the frequency polygon. We need dash, right? We have to fill this of the class interval of x-axis and the frequency of the respective class on the y-axis. So clearly the frequency, its y coordinate, right, is the frequency, and the x coordinate has to be what? The class mark. So the C is the correct option in this case. The question says that in a continuous frequency distribution, class mark is 15 and the lower limit is 13. We have to find the upper limit. For that, same as we will take this formula. So the class mark is what? Class mark is lower limit plus upper limit divided by 2. So class mark is same as midpoint. So what you can say that here the class mark is given as how much? 15. So we'll be replacing this with 15. So let's say if I take this as 15 as the class mark and the lower limit is given as 13. So we'll be replacing lower limit with 13. Upper limit we don't know. Let's say I took this upper limit as x, that divided by 2. So if I multiply 2 on the left hand side, it's going to be 30, and then I'm going to transpose 13 on the other side, right? So it's 30 minus 13 is how much? 17. So 17 is what? The upper limit, and upper limit 17. That is option D in this case. In this question, it says if let x be the class mark and y be the upper limit of the class interval of a continuous distribution, then the lower limit is what? So this is what we are going to apply the same formula, that is class mark. So class mark is lower limit plus upper limit divided by 2. So as you can see that what we are given here, the information that we already know from this is what we have to get the lower limit, and I can replace the class mark with x, sorry, this is class mark with this, which is x, and the lower limit, and y being the upper limit, right? Y being the upper limit. So the lower limit is missing. I can take this as L. For lower limit, I have to get x, L, sorry, and plus the upper limit, and the upper limit, as you can see, it's given y. So I can write y over 2. Now, if I transpose 2 to the other side, it is 2x, and later L on transposing will give you what? Y as this. So we'll say that was the correct option over here. Yeah, that's B is the correct option in this case. In this question from statistics, it says if n is the midpoint and L is the upper limit of a class in a continuous frequency distribution, then the lower limit of the class is what? So for that, you should remember the formula of class mark. Let's say if I write down the formula, we have this as the formula involved, that is class mark is equal to lower limit plus upper limit divided by 2. So let's plug in the value. Class mark is what? The midpoint, right? Class mark and midpoint are same, so I can write m over here. The lower limit is what we have to find out. So let's say I take this lower limit as x as of now, plus the upper limit, which is, as for the question, is L. So I'll be replacing this as L, that divided by 2. So on transposing this side, this is 2m is equal to x plus L. Transposing L to the other side, it is 2m minus L is equal to x. So we'll say that the lower limit in this case is 2m minus L. And what is that? 2m minus L. That is B is the correct answer in this case. The question is, one of the sides of a frequency polygon is what? Is it x-axis, y-axis, either of the coordinate axis, or neither of the coordinate axis? So if you remember how a frequency polygon looks like, this is what you can see, that this is a frequency polygon. And as you can see, why it's called a polygon, as it's a close-sided, right? It's a closed curve made up of only line segment. If I can show you once again, it's only made up of line segments. That's, you can line segment, line segments, line segment. And it is a closed figure, right? Why? Because you can see that it is bounded from all sides. So this is what a frequency polygon, right? So this is a polygon. Now look into this. If I look into the sides, one of its side is what? One of its side is the x-axis, right? One of its side is x-axis and not y-axis. So the correct answer for this will be what? That's option A in this case. So what you should know, that areas of rectangles in a histogram, right? We are talking about histogram. In a histogram, the areas of rectangles, these areas, I mean to say, these rectangles, the areas of these rectangle are proportional to the frequency of the histogram, right? Proportional, you understand, that means are in the ratio, same ratio. So these areas, whatever the areas of this rectangle, let's say, for example, frequency is 10, then this is proportional. This over this should be, let's say, for the third, fourth class, should be like this, right? So it should be proportional. That's what it means. Their ratio should be equal. And it's very important to understand. And for that, I have taken this table. As you can see, this is the first one is incorrect representation. And we'll figure out why. As you can see here, the class size is not same. And look into the class size is 20, then 10, then 10, then 10, then 10, then 10, and then 30. And a student, if he or she has, if represented the diagram like this, what will be the interpretation of this graph? One may think, just looking into the graph will say that more students are there in the range from 70 to 100 marks. There are more students. As you can see, area seems to be large, right? So by just looking into the diagram, one can say that the area more area is there, and therefore there are more students who scored between 70 to 100. But when you look into the data, there are only 8 out of 90 students who actually scored 70 or more than 70. That's the reason why we draw an adjusted frequencies. That's what called the adjusted frequency. So as now when you look into the data, when you look into this graph, you'll figure out, yes, it is proportional. As you can see that the frequency is 7 over here between 0 to 10 and 10 over here. So what is the reason I have taken this graph to understand this question, that whenever you are asked in a histogram about the area of the rectangle, make sure you remember that it is proportional to the frequencies of the histogram, right? And not the x-axis. Just like I have taken one question as of a true and false. It says, is it correct to say that the histogram, the area of each rectangle is proportional to the class size? We'll say no. It is not proportional to the class size. Remember, it is not proportional. The area here is not proportional to the class size. In fact, it is proportional to the frequency. Okay, if not, correct the statement. So the correct statement will be, we will say that the this is what I have already written. You can write down this again, that the area of the rectangle is proportional to the frequencies in a histogram. Based on the same concept, I have taken one more question. That's an assertion reasoning. It says that assertion, in a histogram, the area of the rectangle is proportional to the class size. Area of this rectangle is proportional to the class size. That's very incorrect. As I told you, the area of this rectangle is proportional to the frequency and not the class size. So assertion is clearly wrong. Now, if I see the reason, what does the reason says? To draw the histogram, continuous frequency distribution with unequal class, like as you can see, it's an unequal class. Here the class size, as you can see over here, this is 20, then 10, and then 10, and so on, and here over it is 30. Now the frequencies of the adjusted formula, they are talking about the adjusted frequency. This is the adjusted frequency. If you look into the adjusted frequency here, and they are saying that adjusted frequency is minimum class size divided by class size. That's correct. I can see this is the minimum class size. Okay, fine. That's a bit alteration. That doesn't make difference. This is minimum class size, right? Divided by the class size of, divided by the class size. This is the class size or the width of the class, that multiplied by the frequency. So that is correct. As you can see that they just have written this multiplied frequency, right? So you know that, like if I multiply this, replace these two, they are going to be same. So that is whether we write minimum class size over here into frequency, or frequency over here and minimum class size over here, that's all the same. So we'll say that here the reason is correct, and but assertion is wrong. That's what you have to remember.